Hypothesis test for population proportion. A researcher claims that 86% of college graduates say that their college degree has been a good investment. You have a random sample. 1,000 graduate students, 845 of them say yes, the college degree has been a good investment. And alpha equals to 10%, do you reject or support the researcher's claim? I'm going to show you two different methods to solve this problem. First of all, we're going to use rejection region, then we're going to jump into p-value. To follow the rejection regions, first you need to check to see if NP is more than equals to 5, NQ is more than equals to 5, then state the null and alternative hypothesis based on the keywords, specify the level of significance, determine the critical value, determine the rejection region, find the standardized test statistic, then check to see if this number is inside the rejection region or not. So let us take a look at the steps. First, NP must be larger than equals to 5, NQ must be larger than equals to 5. N is 1,000, you have 1,000 graduates. And P is the population proportion guessed value, which is 86%. So 1,000 times 86% is 860, which is more than 5. NQ, N is 1,000, Q is 1 minus 86%, which is 14%, 140. So we're good with the first step. NP and Q are more than equals to 5. Now, what's the null hypothesis, alternative hypothesis? So let us look for the keywords. This researcher claims that the college degree has been a good investment. They say, hey, their degree is a good investment. So your null is given. The proportion of population say it's a good investment is 86%. So your null hypothesis is given to you. Proportion is 86%. The alternative hypothesis is not, it's either less than or more than. So we have a two-tail test. It means that half of the rejection region is on the left-hand side, the other half is on the right-hand side. But how do we find it? Remember that your level of significance is equals to 10%, 5% on the left, 5% on the right. Let's take a look at our calculator to find this z-value. Let me share the screen with you so you see what's going on here. To find the rejection region, critical value, you need to use this 10%. Again, since you have a two-tail test, half of the area is on the left, the other half is on the right. So what are you going to do? You're going to go to second, vars, and since you're looking for your z-value and you have the area, you're going to use inverse norm. Again, half of this area is on the left-hand side. So we're going to use 5%. 10% divided by 2 is 5%. This is 5%, mean is 0, standard deviation is 1. And since I'm using the area on the left-hand side, I'm going to select left. And when you click on calculate, it gives you negative 1.645 on the left. And because of symmetry, 1.645 is on the right-hand side. Very good. So let us move on and calculate the standardized test statistic. To calculate the standardized test statistic, you have p hat minus p. P hat is the probability of success or proportion of success in your sample. You know that in a random sample of 1,000 graduates, 845 said, hey, the graduate degree has been a good investment. So what is p hat? P hat is x, the number of people said yes, divided by the total number of people, 845 over 1,000, which is 0.845. This is your p hat, minus p, which is the guessed population proportion, 86%. On the denominator, you have p times q. P is 86%, q is 1 minus 86%, which is 14%, divided by n, which is 1,000. The standardized test statistic is approximately negative 1.37. Negative 1.37 is outside the rejection region. So since it's outside the rejection region, you're going to say that, hey, we fail to reject the null hypothesis. We support the null hypothesis. We support the claim that %86 of college degree is useful for graduates. Or basically, there is not enough evidence at the 10% level of significance to reject this claim. This is using the rejection region. Now, I expect you to ask, how do I use the probability, the p-value? First of all, here you have a two-tailed test. And you have a two-tailed test to find the p-value. P-value is 2 times the area in the tail of standardized test statistic. If p-value is less than or equals to alpha, you're going to reject the null. Otherwise, you're going to say that, hey, we support the null. Let us take a look at our calculator. Our calculator is very useful to help us do the computation here. Let us share the screen with you. So here, you're going to go to test on statistics. For proportion, since you have one sample proportion, you're going to go on this number on my calculator is 5. It might be different on your calculator. The functionality is 1 minus 1 proportion z-test. So let's go to 1 proportion z-test. P proportion for population is 86%. X is how many people said yes? 845. So 845 said yes. Out of how many? Out of 1,000. And since it's a two-tailed test, you're going to select the first one. Let us do the computation. When you do the computation, your p-value is about 17%. So p-value, which is this number here on the third line, is 17%. 17% is more than 10%. Since it's more than 10%, we're going to say that, hey, we fail to reject the null hypothesis. It means that we support the null hypothesis or we support this claim. No matter if you use p-value or the rejection region, the outcome must be the same.